D2DNY, Real World HVAC Simplified. And now, in this video, the Real World HVAC Thermostat Board. Alright, so I have a contraption. Not a contraption. This is actually something. Alright, so if you want to know about what you're seeing here, in the Real World HVAC Thermostat Board, I want you to click the subscribe button right now if you haven't subscribed, and smash that bell icon so that when I upload videos like these, cool videos like these, really cool videos like these, you get them right away. All right, so I have here a high pressure switch. All right, I have here, the title says what the video is going to be about anyways, and I have here a low pressure switch. Okay, from the title you know what this video is going to be about. But before I get into this video, before I started explaining what you're seeing here, what am I doing with this tank? What is this tank doing here? This is a nitrogen tank. This is a gauge manifold. You got a thermostat. It's live. It says cooling. Before I get into explaining what's really happening here, you guys gotta subscribe and smash the bell icon. Check this out. I'm gonna turn the light off. Glows in the dark. Isn't that cool? Wow. Glows in the dark. A gauge manifold that glows in the dark. Glows in the dark. YouTube. Look at that. You can read that. Actually, you can read that. Okay. And again, light it up. Okay, enough of that. Let's get into the video. So, like the title says, this video is going to explain how high pressure switch and the low pressure switch works. Okay, so I have a high pressure switch right here. This one here, as you can see, is the manual reset, right? And the ranges on this is you can see 410 psi is going to open at 410 psi, at 410 psi, and that's it. Because it's a manual reset, it will reset. Interesting. They didn't show what pressure it'd be able to reset at, but it says plus or minus 15 psi. So I'm assuming once we hit 395, I don't know. We'll test it. Okay, but at 410 psi, this puppy will cut out on high pressure, and it will not reset or go back online until you hit this button right here. You gotta press this button. Right, it's gonna make a click once you press it. We're gonna do all that in this video. We're gonna actually trip this at 410 psi over here. This gauge manifold needle is gonna. By the way, this is a gauge manifold because this video, being that this video is geared towards do-it-yourselfers and beginners, pros too. Even though this is a pro set right here, but beginners and do-it-yourselfers, you're welcome. So this is a gauge manifold. All right, this is what it's called. This is the high pressure side. This is the low pressure side. It's what you use to measure pressures in the system. However, as opposed to having a hose connected to here, I put the high pressure switch, which is the high pressure, the hose that goes to the high pressure side of your refrigeration system. I put the switches over here so I can test. The high pressure switch over here so I can test. And as opposed to having the hose over here, I screwed on the low pressure hose that goes to the low side of your system to check system pressures, which is going to usually be a blue hose. This usually be a red hose, hence the colors red, blue, the needles. Okay. So yeah, I just put the switches on here instead. And this yellow hose is a charging hose, right? The middle port is the charging port. So what I'm gonna do, I'm gonna have nitrogen be charged pressure up into the gauge manifold while I open my high side valve, it will allow that pressure to go through, and I can trigger the switch. I could trip it. Right? Same thing. When I open my low side, once I have my nitrogen tank, this is a nitrogen tank, by the way. All right? This is a nitrogen regulator. I'm going to be turning that down a little bit. All right, just to demonstrate. Okay. Oh man, lots of stuff going on in these videos, man. This is a transformer right here, which I'm using to run this thermostat. All right. No Wi-Fi though. This is a pretty cool thermostat. This is how you lower the temperature. All right, and you raise the temperature. Right, that's dope. It's a little slide. This is the Google Nest. And if you tap on it like that, right? Scroll down, fan, you know, whatever. But this is not what this video is about, right? So yeah, let's get back to what it's about. This video is about high and low pressure switches, right? So last but not least, we have the contactor. This is a contactor which you use a low control voltage on the coil right here, which in this case, coil voltage is 24 volts. Okay, so yeah, this is 24 volts. Transformer is 24 volts. Steps down is a step down transformer. Step high voltage down from 230 or 460 down to 24. Oh crap, I'll put it on later. So this transformer basically is going to simulate what's going to happen if I trigger my low pressure switch is activated or active or deactivated, or my high pressure switch is activated or deactivated. So right now it's actually wired, these wires from the thermostat. Oh, come on. The wires from the thermostat is actually connected. So this thermostat is actually doing cooling right now, and my cooling signal is actually coming down. However, okay, just reconnected my common. That's my common right there, 24 volts hot going to my thermostat. So, okay, so this wire, this yellow wire, is connected back here. It's coming out the thermostat, the cooling signal. Okay, so the cooling signal is coming to this wire right here. And as you can see, real time, I'm going up into my high pressure switch. And then out of my high pressure switch, you see. So the yellow wire is a cooling wire, cooling signal, 24 volts. Goes into my high pressure switch. Out of my high pressure switch, as you can see what's going on here, I'm going into my low pressure switch. And out of my low pressure switch, I'm going into my compressor contactor. All right. But my compressor contactor is not on right now because we are below the threshold where my low pressure switch is to be active. Remember, this low pressure switch right here has a range on it. Rotate so you can see it. It closes at 65 and opens at 25. You can see that right there. Now this particular switch, our low pressure switch, is for a R22 system, refrigerant R22, potentially R47C. All right, because at 65 psi, it will close and allow the system to work or to operate. 25 psi or below 25 psi, it will cut off as a safety to prevent the system from running while it's low on refrigerant. On the opposite side, this switch right here is a normally closed switch, so it's going to be closed at all times except when the pressure is above 410 psi, and there's a plus or minus 15% of accuracy, so we see that one goes. But the ratings on this is 410, and on 410 psi safety cutoff, this is definitely going to be a R22 switch as well, because if it was a R410A, it will be 500 or maybe 610, something like that. I think so. All right, you can comment in this comment section if you know exactly. But typically in an R14A system, the cutoff pressure would be at least 500 for water cooled system, and then if it's air cooled, it will be like 610 psi. All right. As a matter of fact, this is the box for the high pressure switch, and the version I'm using right now is the SMR410. If this was a our 14A system, this switch will be using this switch right here, 610 psi. Okay, so yeah, again, this is not really set in stones. Different manufacturers might choose to make a special switch just for their equipment. What you do, guys, when you have a situation like this, you want to know what your switch is capable of handling, what's the cutout or cutting point. It's going to be on here. It's going to be written on the device. All right, so that's it. That's how you solve that problem. Okay, enough of that. Okay, now we're going to get into some testing, right? Again, if you got questions about this, leave in the comment section. Okay, so the first thing I want to show you guys, right, is how you can actually bypass these switches. How do you bypass them? Now, because I did a video, and I'm going to leave the link to that video in the description. I did a video with these switches on an actual real world, real-time HVAC system or HVAC unit, and it was running. System was running. I did a video on that, but there's a lot of questions. How do you bypass it? So I'm going to show you simply. So right now, we know that the normally open switch is open, which is a low pressure switch. It's normally open until the pressure is up. This particular one is rated for 65, so once the pressure goes up above 65, it will be closed. So even though we're calling for cooling, and my system is wired up just like a regular system, my compressor contactor is not energized, which means my compressor is off. So let's just say I'm Mr. Joe Hack or Joe Hacker, Hacker Joe. I walked up, customer said, "Hey, my system and my compressor is not running. I don't have any cooling." All right. I go ahead and I put on my gauges and I see that I have 0 psi. I said, "Hey, maybe because I have 0 psi, my safeties must be open or tripped." So what do? So what does Mr. John Hacker do, or John Hack do? He takes the wires. Now these wires doesn't have any wire nuts or anything like that, because it's just demonstration purposes, and it's a 24 volts. It's low volts. I'm not grounded. Plus I know what I'm doing. Okay. Is that a mosquito? Yeah, that's a mosquito. I gotta get that sucker. Ah, yes, got him. Sorry for that, guys. But I hate mosquitoes, man. All right, back to what I was saying. So Mr. John Hack came in. He's like, "Okay, customer, I could solve that problem. The compressor is not on. Okay, here's what I'm gonna do. I'm just gonna get it on for you right now. You hear that? Now the compressor is on. Right? Just by doing this. What does he do? All he did, he bypasses the low pressure switch. He bypasses it. You get it all together in one frame. So he bypassed that. That's what John Hack does. When the customer, after he pays John Hack $25 or $20, just so he can buy beers and cigarette, he realizes AC is still not blowing cold, or he doesn't have AC still, he calls D2D, the pros, right? D2D comes in and do a leak check on the system, solve the problem, and then he does what? He's going to charge the system up, right? So let's open this up. We're going to charge up the system. We're going to add some refrigerant. We're going to make believe this is refrigerant. We're charging it up right now. All right. It's very pro. All right. Charge it up. Now we got good pressures. Our compressor is on. It's running. Well, let's demonstrate what's going to happen if we have a slight leak. So I'm going to lower this. I'm going to crack this. Once it passes around 25, it kicks off. Okay, let's reopen this. Back it up a little bit, reduce the pressures. Open the main valve, still at 0. Then I'm gonna go ahead and just turn this down slowly to bring the pressure up. I want to bring it up slowly this time so you guys could see it. Okay, so I'm gonna turn it down some more. A little bit more, a little bit more, turn it down. Turn it down. See, it still didn't make. We need to hit, remember the cutting point on this switch is 65. Cuts out the 25, so you gotta go above 65. Turn it on some more. Slowly. Turn it on some more. So we get it right. That's 50. 55. 60. Let's see how accurate this switch is. 65. Wow. That's on the money. Wow. All right, let's release it and see the other way around, right? Close it out. Let's see how we can release this thing right now. I'm gonna crack this right here, lay it out. It's going down. Okay, so we're still on. Didn't trip us yet. We have a refrigerant leak right now. We're leaking out slowly because Joe Hack fixed the leak. Did no good job. Woo! On the money. Bravo. All right. Now let's go test the high pressure switch. And I'm going to show you how to bypass it too. It's the same concept, but I'm telling you right now, I do not recommend any such thing. Do this at your own risk. Always fix the system, fix the unit the right way. Don't do any shortcuts. Don't be Mr. Hacker. Do the right thing for your customers, all right? They'll appreciate you. All right, so to bypass the high pressure switch, basically is the same thing. You take both wires from the switch and just short them together. So we're going to go ahead and trip this switch. We're going to trigger it. We know we got to go up to 410 psi, which means, so let's just close this gauge right here. So we're done with the low side. As a matter of fact, I got to build the low side up and close it off so that we are staying online. Okay, so let's build that up. Okay, so we're good. R22, 75 psi back, we're good. So close that off for now. We're going to close this off. We're going to hold that pressure there. So the pressure is going to be trapped here. All right, so it's going to maintain. Now, we're going to build up the high side. So we can trip this switch. We're going to trip it. We're going to increase this pressure. Turn this in. Build the pressure. I want to go to 410. You're going to trip. Now remember, my compressor is still on. You can see me. I'm doing cooling, baby. All right, so I'm going to trip this high pressure switch. Increasing my pressures on my regulator. Turning that in. And this needle, that's the tank needle. Which one is the tank needle? I think this is a tank needle. Is it? Let's see. Okay, this is working properly. I'm not even quite sure. Nonetheless, it's not what this video is about. Alright, so we're at 325. Turn it in some more. Alright, let's see where it's going to trip right now. Alright, come on. 400. Okay, we got to go 405. 410. Don't do it. 410. Oh, crap. That's it. I'm done. I'm out of nitrogen. That's crazy. Wow, guys, I gotta go get another tank. It's like I am at right there, very close. It's not enough. All right, stay tuned. Crazy, change this tank right now in the middle of my video. Come on. All right. Just bear with me, guys. Almost there. Reconnecting. reassembling. This one is pretty much empty. All right, nice and tidy. So now let's continue. I'm gonna reopen this. Ooh, pressures are crazy now. Look at that. So you know what? I'm gonna release this first. Back this out because I want it to drip slowly, so you guys could see it. I don't want it to drip like right away. Okay, let me just see what I got right now. If it's gonna go. Oh, there you go. So we're at 420 and we're tripped, baby. We're tripped. Now, one thing I'm gonna tell you guys is that even though I don't recommend bypassing any safeties, well, this one even go creeping up too. My gauge is leaking. I don't know what's going on here, but anyways, even though I don't recommend bypassing any safeties at all, right? You could take a chance if you want to take the chance. If you're, let's just say this switch is bad and it's an emergency and you got to give the customer cooling, bypass this one. That's fine. Bypass the low pressure switch. However, on the I side, if this is what you have right now, you see what you got? 420 psi. The safety is tripped. It won't be able to reset right now. If you hit this button, nothing won't happen. Nothing will not happen because the pressures needs to go down to a certain amount before it can be reset. Okay. So the first thing I'm gonna show you is how to bypass it, how to bring your compressor back on, and simply, just like the low pressure switch, you take the two wires on the switch and touch them together. Come on, what's going on here? Now, can you imagine trying to start bypassing your high pressure switch, starting your compressor while the head pressure is 400 plus psi? You could ruin the compressor, blow the fuses, ruin the contactor because there's going to be a lot of amperage draw, blow out the compressor terminal and hurt yourself, burst your coil. A lot of problems could happen from bypassing the high pressure safety switch. It's very dangerous. I wouldn't recommend it. If you, in worst case scenario, you can bypass this switch on an emergency, but this one, the high pressure switch, no, I don't recommend it. Go get the part. It didn't work the problem. All right, it didn't work the liability as well. Now, just so you know, the same way how you have a automatic resetable low pressure switch, the high pressure switches comes this way as well. This particular one, I just want to show you guys that it's a manual reset. So, you know, if you have a similar one that has the ranges of the high pressures on it, then it's a high pressure switch. And it will look similar to this. As a matter of fact, I'm gonna see if I can find one and show you guys before the video is over. But it looks the same way as the low pressure switch right here. And what physically is the same appearance, everything is the same, except most likely you'll have a black wire on it as opposed to a blue wire. And yeah, most likely. Sometimes the wires, don't go by the wires, go by the tag, the little tag on it, read it. If it says 410 or 500 or 610, that's a high pressure switch. Okay, it's going to be normally closed. All right, and it's going to open whenever there's a problem, breaking the circuit. All right, so now let's bring this back down so we can do our reset. All right, so I'm going to close this off. And I'm going to release my pressures. All right, let's just see if we stop at 350. Okay, I think I've already heard the little click from right here. Let's see if I hit the reset right now, if it will work. Yes, now it's reset. Now let's trip it again. Second time. So we got time in it. Now if you like this video, give it a thumbs up. If you haven't subscribed, subscribe. I do upload videos on a weekly basis. Is this thing opened or not? Okay. So we're open. What's going on with my pressures? Why am I not going up? Okay, here we go. Go up. 405, 410, 4. Ooh, that's right on the money there, folks. All right, so I'm gonna go ahead and close this. It's closed, and then I'm gonna go ahead and release it because right now I can't reset it. Right? Remember, there's a differential in this thing. So let's see exactly what pressure is going to relieve itself. Listen for that click. And I'm gonna go ahead and release this. Okay, let's try right here. Nope, it's not resetting. Some more down. There it is. I heard it. I think it's 300. So let's get it again. Listen for it. Yes. All right. That's it for this video, guys. If you're still here, you're special. If you'd like me to do a lockout logic or lockout relay, let me find one of these for you. Hold on a second. Here we go. If you'd like me to do a video with this lockout relay, there's two of them in here. If you want me to wire this up, if you want to see me wire this up in this control circuit here, right, with this compressor contactor, all right. If you want any explanation of anything you see here on this board, even these cool gauges, right? Remember, they glow in the dark. Okay. If you want me to do any explanation, if anything you see here, just leave it in the comment section. I'll do it. But if you want to see a video, me do a video where I install this right here in this real thermostat board, real world. It's not real. This is not really real world right now, but this is a real world HVAC thermostat board. If you want to see me do a video of this relay here installed, working with this compressor contactor on the high and low pressure switches, yeah, I need at least 10 people to comment that they want to see it. And then I'll make is it a spider? Wow, that's crazy. Okay, mosquitoes and spiders. Yeah, I need at least 10 people to comment that they want to see a video, want to see me wire this up to this old contraption. All right. So if they comment, 10 of them would comment, then I will do it. If I build it, they will come. I have two of them in here. You can only put one of them in this circuit though. Two would be an abomination.